We've all dreamed of visiting the Arctic and witnessing the natural wonders of polar bears frolicking on ice floes or the aurora borealis dancing across the sky. Well, sorry to break it to you, but you won't find any tourists flocking to Antarctica anytime soon. Why, you may ask? Let's dive into it. First off, where is Antarctica? It's located in the southern hemisphere, specifically at the South Pole. The Southern Ocean surrounds it, and most of the continent is covered by ice, making it one of the most remote and frigid places on Earth. Now, have you ever met someone who's visited Antarctica? Probably not. It's one of the least visited places on the planet, and only a handful of lucky explorers have seen its interior, which is mostly made up of glaciers and ice fields. But trust me when I say the wildlife and scenery are out of this world. Why shouldn't you travel to Antarctica? Well, for starters, the environment is incredibly fragile and can be easily damaged. Plus, there are no native human populations on the continent, so your travels would essentially be like visiting an uninhabited island. And let's not forget that it's also one of the most expensive destinations to travel to. Despite all that, Antarctica is not exactly guarded like a fortress, but there is an international agreement called the Antarctic Treaty. This treaty was negotiated to prevent any unwanted activity on the continent and bans some forms of testing done there by member states. But the primary reason we can't just waltz into Antarctica is that it has a delicate ecosystem that needs protection. The treaty states that Antarctica should be used for peaceful purposes only and should be free from any human activity that could harm the environment. Scientists are still learning about the continent's unique ecosystem, and our activity and machines could disrupt the delicate balance that exists there. If you're still itching to go to Antarctica, getting permission isn't exactly a walk in the park. U.S. citizens, for example, need to complete a special form and send it to the Office of Ocean and Polar Affairs. And once you're there, you'll need to follow some strict guidelines to protect the environment, like not disturbing any wildlife or taking souvenirs like rocks, plants, or animals. Now, technically, can you live in Antarctica? While there are no laws banning people from living there permanently, it's a very inhospitable environment and unsuitable for human habitation. Temperatures can reach -76 degrees Fahrenheit and below, making it nearly impossible for anyone to survive without the proper equipment and experience. Plus, the nearest piece of land is over 1,000 miles away, making any inhabitants completely cut off from the rest of the world. Who knows? Maybe one day we'll get the chance to visit this unique and fascinating continent. But until then, let's admire it from afar. Let's now talk a bit about the discovery of Antarctica. Unlike other places that were already inhabited, Antarctica never had a native human population. Ancient Greek philosophers had an idea about the continent and called it Antarctos, meaning opposite the bear. The bears it refers to are not the polar ones though, but rather the Great and Little Bear constellations, which are only observable in the northern hemisphere. As a result, the term signifies the opposite of the land of the bear. Whaling and sealing voyages in the late 1700s and early 1800s would venture further south when rounding Cape Horn at the tip of South America. It was known that going further south often meant stronger winds, but also the risk of hitting floating ice of all sizes and of winds and seas that could prove dangerous to the ship and crew. Captain James Cook was the first to cross the Antarctic Circle on January 17, 1773, in the Ross Sea region. He reached a point further north a year later, and though he didn't sight land, he came to within 50 miles and saw deposits of rock held in icebergs, indicating that a more southerly land existed. The first sighting of Antarctica is widely acknowledged to have taken place in January of 1820, during the voyage of two ships under the command of Captain Fabian Gottlieb von Bellingshausen, as part of a 2-year exploratory expedition around the world to discover new lands. The captain's ships were the first to have crossed the Antarctic Circle since Cook. The first undisputed landing on Antarctica didn't happen until much later, on January 24, 1895, at Cape Adare during the whaling voyage of the ship Antarctic, led by Henrik Bull. A small boat with 6 or possibly 7 men on board rowed ashore during calm conditions. You might not believe it, but Antarctica is actually a desert. With all that ice, you'd think it'd be like a winter wonderland with snowball fights and hot cocoa all day long. When we think of deserts, we picture camels and cacti and people struggling to find water. But in Antarctica, it's a whole different story. The struggle isn't to find water, it's to find anything that's not covered in ice. And the average rainfall has been just over 0.4 inches in the past 30 years. That's like a few drops of rain compared to what we're used to. So technically, it's not the dunes or sizzling heat that makes a desert, well, a desert. It's the lack of precipitation. But don't worry, if you ever find yourself lost in Antarctica, you won't have to worry about getting thirsty. Just make sure you bring a jacket and some mittens, because it's cold enough to make you into a popsicle. Not only is Antarctica one of the driest places on Earth, but it's also the coldest, the windiest, and the highest. Talk about overachieving. The penguins and scientists down in Antarctica have at times found themselves in a bit of a pickle when it comes to time. You see, unlike the rest of us on this big blue planet, there is no Antarctica time zone. All the lines of longitude meet at a single point at the South Pole, making it a bit of a head-scratcher when trying to figure out what time it is. Now, you might be thinking, but how do the scientists and researchers keep track of time down there? Good question. They typically stick to the time zone of the country they departed from. However, with stations from all over the world on the Antarctic Peninsula, things can get a little wacky. Imagine trying to coordinate with your neighboring countries without accidentally waking them up in the middle of the night. You might think that not much could survive in a place where the temperature is extremely cold, the sun barely shows up, and the wind could blow you away faster than a tumbleweed. Well, as in many places on Earth, life found a way in Antarctica too. Believe it or not, this frozen continent is buzzing with activity. It's home to billions of krill, which in turn attract lots of seals and more penguins than you can shake a fish at. But don't let their cute and cuddly appearance fool you. Penguins are the ultimate swimmers, with streamlined bodies that would make Olympic medal winners jealous. They come ashore to breed and chill, but their real talent is stealing pebbles from each other and forming mathematically precise huddles to stay warm. Antarctica is also home to the largest species of penguin on Earth. It's called the emperor penguin. Sure, these creatures are flightless birds, but that doesn't mean they can't jump. In fact, some of them can leap up to 120 inches. And let's not forget about the seals. With their furry bodies and special songs, these marine mammals are protected by the Antarctic Treaty, and they're thriving in the cool waters of the Southern Ocean too. But the real stars of the show are the whales. During the Antarctic summer, these huge creatures show up in droves to chow down on the abundant krill. It's indeed like a whale buffet down there.
Scientists just drilled through about 1,700 feet of Antarctic ice and pulled up a record-breaking core. It's a 750-foot tube that reaches back about 23 million years. The core showed that this part of West Antarctica had been an open ocean back then. That means the ice sheet had collapsed before. And if it sinks again, global sea levels could rise enough to turn coastal cities into aquariums and rewrite the map of the world. To learn more, an international research team set up camp at a spot called Prairie Ice Rise. It's like a giant frozen raft stuck to Antarctica, caught on rocky bumps on the seafloor. Those bumps act like a brake, helping hold back the inland ice. But warmer ocean water is starting to melt the raft from below. If the ice thins and lifts off those rocks, the brakes are gone, and the inland ice is going straight into the ocean. That is why scientists decided to drill here. Drilling a straight hole through a third of a mile of ice sounds impossible. It can't be done with a regular drill. Instead, the crew had to use a custom hot water drill. It's basically a superheated pressure washer. It shoots near boiling water straight down to melt a vertical tunnel about 1 foot wide. The problem is, the ice tries to heal the hole shut. The continent itself is saying, nope. If the hot water stops flowing for even a little bit, the tunnel starts freezing again and the hole begins to close. And since they were in the middle of a frozen wasteland, they had to set up a small camp of tents with its own power supply. The nearest station is about 450 miles away, so any serious breakdown could mess with the whole project. For comparison, the space station is about 250 miles above Earth's surface. So this expedition had to be planned almost like a space mission. Granted, the ISS is still harder to reach, but you get the point. If the camp lost power, the researchers would have to fix it fast, within 1 or 2 days, or the hole could freeze shut completely. You might already know that ice can trap ancient microbes and particles from the air. Snow falls, freezes, and stacks up in layers. Each layer traps whatever was floating around at the time, stuff like dust or gases, even tiny organisms. That's how scientists read the past. Those stacked layers are called ice cores, but the researchers weren't after the ice. What scientists recovered there is a sediment core. Instead of frozen snow, it's a long tube of mud and rock drilled from the ocean floor under the ice. Think of it like this. Ice cores record what was in the air. Sediment cores record what was happening in the ocean. Everything floating in the water eventually sinks. When a massive ceiling of thick ice completely covers the ocean, the water below goes pitch black. Without sunlight, there's no way for plants to grow. The only stuff sinking to the seafloor is heavily crushed rock, physically scraped off the land by the moving ice above. When the climate warms, the ice pulls back and sunlight brings back life. The seafloor starts building the open water layer again. Over time, you get a repeating pattern. Gritty rock when it's iced over, pale shell-packed mud when it isn't. It's like Earth creating a barcode for scientists to find. When the drilling crew finally cracked open their giant tube of dirt, the mud was filled with marine fossils, the physical remains of ancient ocean bugs. And those specific bugs absolutely require sunlight to survive. Their entire food chain runs on big algae blooms at the ocean surface, so finding them is big proof that under warmer conditions, the ice pulled back completely. The total disappearance is the scary part about how West Antarctica behaves. The ice doesn't simply melt away inch by inch in a slow, predictable way. It has a built-in tipping point. Finding those deep-sea fossils suggests that once the ocean gets warm enough to lift the ice and release that rocky parking brake, the whole frozen raft can suffer a full system failure. It might basically vacate the premises, and that kind of collapse is what makes scientists nervous. Researchers call this one-way behavior hysteresis. This is Billy. He's sitting on a sled at the top of a snowy hill. The sled is pointed downhill, but Billy isn't moving yet because the snow is still holding him in place. Then someone gives the sled a tiny push. At first, it's just a slow creep. But once the runners start sliding, gravity takes over and the sled picks up speed on its own. The key part is that even if the person who pushed Billy instantly regrets it, the sled won't stop. Huge ice sheets can work the same way. Push the planet past a certain temperature line and the retreat can keep going on its own. Even if temperatures drop again centuries later, the melting doesn't automatically slam on the brakes. So scientists are trying to figure out how much warmer it has to get for West Antarctica to enter that locked-in mode. One estimate says the danger zone starts at about 3.6 degrees Fahrenheit above the global average temperature in the mid-1800s. They still can't say that's the exact flip point or give a clean countdown. That's what this core is meant to help confirm. But the ice isn't only getting hit from the outside by warmer water. Parts of Antarctica get heat from below too. Near the Ross Ice Shelf sits Ross Island, and on it, an active volcano. It's called Mount Erebus. It rises about 12,400 feet above sea level, and it's the southernmost active volcano on Earth. But the cool part is that inside its summit crater is a persistent lava lake. An actual glowing pool of molten rock that's been churning for decades. That's not normal. Only a handful of volcanoes on Earth maintain long-lived lava lakes. Erebus does it while surrounded by one of the coldest environments on the planet. Antarctica can be brutally cold at the surface, but Mount Erebus is powered by heat from deep inside the Earth. That heat doesn't care if the air above is negative 40 degrees Fahrenheit. Magma rises because it's hot and buoyant. As long as fresh magma keeps feeding the crater and gas keeps escaping, the lava lake can stay molten. Erebus also creates something you rarely see elsewhere. Ice towers built by a volcano. Hot gases escape through cracks, hitting the freezing air and instantly solidify into tall, hollow chimneys of ice. Some of the caves inside those towers can be surprisingly warm compared to the outside air, creating strange little pockets where microbial life can survive in the dark. Another cool thing about this region is the miles of subglacial lakes. Some are the size of small cities. Pressure helps keep them liquid and heat from below keeps them from freezing. A bunch of them connect through hidden channels, so they fill and drain like an underground plumbing system. Satellites can even catch the ice above rising and falling as the water moves. Erebus matters because it proves West Antarctica can get heat from below. That heat can melt the ice at the base and create water underneath. Those buried lakes matter because that water acts like lubrication. Less friction means the ice can slide faster. And when lakes fill and drain, that slippery layer can shift around suddenly. When grip and support both weaken at the same time, that sled doesn't need much of a push. There's no doomsday clock on the wall counting down to some dramatic end of the world. Even if West Antarctica starts sliding into the ocean, it wouldn't happen overnight. Coastlines would shift inch by inch, one storm at a time, with decades in between. Cities wouldn't vanish with a single wave. We'd have to do a lot of redesigning and moving. And centuries from now, if parts of today's coastline sit underwater, future divers might swim past the tops of skyscrapers the way we dive through ancient shipwrecks.
A colossal iceberg, more giant than a city, broke away from Antarctica in mid-2021. It's so big that it's 40 times bigger than Paris and 73 times the size of Manhattan. Imagine that you come out of your small holiday shack on the coast of South Africa, near the town of Port Elizabeth. You have a cup of tea in your hand as you've just woken up. You stand near the edge of your lookout, the vast Indian Ocean before you. Something catches your eye. To the right, there is something so monumental, you can't comprehend it. It's a giant slab of ice, 300 feet high, and stretching away many miles, as far as the eye can see. It rolls slowly, but relentlessly on, heading out into the deep sea. If it goes far enough, it could reach the western coast of Australia. Playing in front of it are a pod of dolphins, like they sometimes do off the bow of a ship. Yet they're just specks compared to the mammoth size. You're so shocked that you drop your cup. Your eyes are as big as saucers. It's like something out of a science fiction movie. Are you dreaming? Are you seeing things? Nope. It's A76. It's real, and it's currently on the move. What could happen to it is anyone's guess. Well, scientists have a few theories, but let's get a grasp of its size first. The iceberg is 110 miles long and 16 miles wide. It's basically the shape of a gigantic finger. If you were standing at the coast of Dover, looking across the English Channel toward France, the iceberg would be almost as wide. The channel is 21 miles across at its narrowest. That means approximately 2/3 of that distance would be filled with the iceberg. That's if it were drifting finger pointing down, so to speak. If it were facing the other way, it could still enter the English Channel, but as it got closer to the narrowest points, it would smash into the coasts of both England and France. It would go up over land. It would slide over the green fields of England, the white ice bold against the rich green. It would cruise past the vineyards of France. It was temporarily lowering the temperature of everything around it. Those grapes would be like jelly crystals. It would skim right over highways, cars stopping to observe this colossal thing, like a visitor from another galaxy. You could pluck chunks off it for your drink as it sailed past. Failing that, you could scale it and go ice climbing, right on the outskirts of London. It would certainly be handy in the summer. But let's get back to what actually happened, and what scientists think will happen to it. As of the beginning of 2022, A76 is the world's most giant floating iceberg. It was calved from the Filchner-Ronne ice shelf in Antarctica in the middle of May 2021. Ice calving, also known as glacier calving, is the breaking up of ice chunks from the edge of a glacier. It then pulls away from the ice mass into a separate entity. If you were nearby, you would hear a lot of cracking and a massive booming sound. Blocks of ice up to 200 feet would break free and crash into the water. It would cause huge waves. Not even adventurous surfers would want to tackle those breakers. Ice calving is a natural event. The area where A76 broke off has seen little change in recent decades. There have been even larger chunks of ice than A76, but this one is currently the largest in the world. Scientists at the British Antarctic Survey spotted it. There are satellite images of it breaking free, as captured by the European Space Agency's Sentinel-1A satellite. The size at the calving was an estimated 1,670 square miles. Right now, it's in the Weddell Sea around Antarctica. The Weddell Sea is part of the Southern Ocean. It was named after the Scottish sailor James Weddell, who entered the area in 1823. Scientists have deemed the Weddell Sea to have the clearest water of any sea. Imagine peering down into its depths from a boat. What a fantastic view it must be. The area is full of whales and seals. As you look down, you may see killer whales, humpback whales, minke whales, leopard seals, and crab-eater seals. And if you look towards land, you'll likely see a colony of Adelie penguins. They're the dominant penguin species in this area because they adapt to the harsh environment. In fact, this is the only location in the world they live. What an incredible array of wildlife to observe, all from the comfort of the ship's deck, while you drink another cup of hot tea. It gets pretty cold in these parts. To get an idea of what could happen to A76, scientists refer to other data, such as the even more enormous iceberg called A68. It was calved from the ice shelf known as Larsen C off Antarctica in 2017. While it may be exciting, though a little daunting, to think of it also sailing up the English Channel, A68 floated out to warmer seas and, by early 2021, had all but dissipated. That was a relatively quick demise. Some icebergs have been observed floating around for up to 18 years. Suppose they remain in the relatively cold waters. It all depends on where A76 decides to go. Satellites have helped scientists keep track of these monstrous movements, whereas they would go unnoticed in the past. That's how they know that by day 148, this iceberg had split into 3 fragments, imaginatively titled A76A, A76B, and A76C. The numbers might be boring, but they're based on the Antarctic quadrant in which they were first sighted. If these enormous chunks do break up entirely, it will not add to rising sea levels because it was already part of the floating ice shelf. Imagine these ice chunks in your glass. They already take up a certain amount of space. They will simply change form into water. Icebergs like this one are different from glaciers or ice sheets found on land. Those are the things that help to raise sea levels when they break off and melt. For example, if the whole of Antarctica's ice sheet were to melt, it could raise sea levels by nearly 190 feet. If you think A76 is enormous, and it clearly is, there was another that makes it look small in comparison. On record, the largest iceberg was sighted in November of 1956, 150 miles west of Scott Island in the South Pacific Ocean. Ironically, it was seen by a ship known as the USS Glacier. It was sized over 12,000 square miles. This iceberg was larger than the country of Belgium. What may happen to the chunks of A76 will depend on a few factors. Ocean currents can make a significant impact, and wind direction and speed can too. They may move closer to coastlines, where they can freeze into pack ice. They can also drift into shallow waters and hit the seabed, called seabed gouging. The deepest part of the iceberg can act like the keel of a boat. It digs into the ocean floor, but the sheer size of the iceberg keeps it moving. Soon it's tearing up the floor, creating a long, narrow furrow or a gouge. Fish would scatter, the earth would shake, the noise would be tremendous. It's actually quite common in offshore environments near where ice is found. You would not want to be scuba diving nearby when one of these rips through. However, it would make for a spectacular sight. Generally, icebergs deteriorate through melting and fracturing, which, as you can imagine, changes the mass and the surface area. Combined with wind and ocean currents, it can make iceberg modeling difficult. As for A76, we'll just have to wait and see. Before we go, let's return to our imaginary voyage down the English Channel. The island of ice, 73 times the size of Manhattan, with its gigantic frosty finger pointed down toward the Celtic Sea, rolling steadily onwards, unable to be stopped. Hundreds of thousands of people have flocked to the coasts of both England and France to watch this extraordinary spectacle as it cruises by. On top of the ice, there are thousands of penguins playing happily. They almost look to be waving back to the abundance of sightseers who cheer them on their way, the children jumping with joy at the most spectacular sight they've ever witnessed.
80% of what's deep inside the world's oceans remains hidden to this day. That's because the ocean covers 70% of the planet's surface, and we only have access to a small portion of that. We can clearly see around 3 miles deep down inside the ocean. So it's no surprise that our most recent discoveries when it comes to wildlife come from the ocean. I mean, there's a lot to explore, like this new shark species called the Genie's dogfish, or the longest animal ever found, a 154-foot-long jellyfish, which we just stumbled upon earlier this year in Australia. Somewhere in the Arctic and Antarctic seas, a strange phenomenon appears, confusing people to say the least. It's called frost flowers, but they're not plants at all, merely ice crystals. Frost grows on the long stem plants that manage to break the thin layer on the surface of young sea ice. Frost flowers aren't just made of water, though. They have a variety of microorganisms within, making them a small temporary ecosystem. Turns out we don't have volcanoes just on the visible surface of the Earth. Submarine volcanoes are just as disruptive to their surrounding wildlife. If the data we have so far is correct, the ocean has the most productive volcanic systems on Earth, most of them being on average 8,500 feet below the surface of the water. A maelstrom, a powerful and at times dangerous whirlpool, is a source of nightmares for seafarers to this day. What sets a maelstrom apart from other whirlpools is that it comes in an extraordinary size and force. It's so powerful, it can even put larger ships in a lot of trouble. One of the most famous of them is called Naruto, and it's located near Awaji Island. Its tides move in and out from 8 to 12 miles per hour twice a day, making it one of the fastest in the world. The sinking of the Titanic is the historical event that made icebergs famous, am I right? Well, sometimes these icebergs even come with colored stripes. They can be brown, black, green, yellow, and blue. Obviously, they're called striped icebergs, and they get their colors from various natural reasons, like the blue ones, for example, which turn up when the ice melts and freezes back up very quickly. If there are green stripes in the iceberg, it probably means it has some algae stuck somewhere in there. Other more earth-tone colors, like brown, yellow, or black, have other things to blame, like sediments the seawater picks up before freezing. Back in March 2019, scientists stumbled upon one of the most baffling phenomena ever to be found in the sea. During the exploration of one of the underwater volcanoes, they noticed what looked like a small lake, which was upside down. It was at least 6,500 feet below sea level. If you think that doesn't make any sense, well, that's because it's not real. Turns out it was nothing more than an optical illusion generated by the liquid in these upside-down pools. It gets up to 320 degrees Fahrenheit hot, and it's made of some harsh chemicals like sulfur and metals, which makes the illusion possible. The world's largest waterfall is also safely tucked underwater. It's located beneath the Denmark Strait, a portion of water that stands between Iceland and Greenland. If you suddenly grow fish gills, dive in there, and manage to comfortably breathe underwater, you'll be able to see a series of waterfalls that begin at 2,000 feet under the surface, but then drop down to a depth of 10,000 feet. In 2011, Swedish treasure hunters discovered an object on the bottom of the Baltic Sea that they described as strange and mysterious. It's oval-shaped with unusual stair formations. The head of the team who made the discovery supposed it must have been constructed tens of thousands of years ago, even before the Ice Age, and could have been part of the underwater city of Atlantis. Experts who analyzed the object believe it to be a regular glacial deposit or some other natural formation, but they still don't know for sure. Now, they don't call it the Black Sea for nothing. Located at the southeastern extremity of Europe, it even has sea smoke, which is basically steam coming out of the surface of the water. This happens because of the humidity of the oceanic water, which neutralizes the cooler wind blowing on the water surface, creating this vapor-like phenomenon. If you ever check out the ocean surface during sunset and sunrise, you might get lucky enough to see green flashes. You'll have to pay attention though, because it merely lasts for a couple of seconds. They happen because of the natural prismatic effect of the atmosphere of the Earth. During sunsets and sunrises, light emerging from the sun gets diverged into multiple colors, a process that looks like there's a green flash emitted by the water. Red tides do happen a lot of times, and although there's no need to panic when you see one of those, you still must be careful. The technical term for this phenomenon is algal blooming. It happens when there's a rapid growth or blooming of algae in the waters of the ocean. Because of the chemicals these algae contain, they may be trouble for birds, animals, and even humans. So don't be so quick to jump into the waters should you ever experience it. Octopuses and squid have a special trait that sets them apart from other sea creatures. They have 3 hearts. Wow, Valentine's Day must be very special for them. It doesn't necessarily make them more romantic, but they do need these 3 hearts to function properly. They have one major heart that helps with circulation all around their bodies, and 2 bronchial hearts that are responsible for pumping near their gills. So, with 3 hearts and 8 arms, when the octopus hugs you, you'll know she's very sincere. Based on a study published in 2013, dolphins have names for each other, particularly bottlenose dolphins, which have their own special whistles, just like human names. Not only do they develop this type of whistle to present themselves to other dolphins, but they can also learn other such names so they can better communicate with each other. In the depths of the Pacific Ocean, there's a mysterious singing whale, which scientists have yet to fully understand. They call it the loneliest whale because it emits sounds at a much higher pitch than any other blue whale we've ever encountered. No one has ever seen it though, so researchers believe its strange tune may be keeping it from actually finding a partner. Aww. Now, standard blue whales have their own particular quirk. Their hearts are more than 5 feet long. They're also about 4 feet wide and can weigh more than 400 pounds. Just to give you a better idea, your heart is roughly the size of your fist, so that would be smaller. Not that we aren't a bit intimidated by sea creatures already, but just so you know, sharks can sometimes grow thousands of teeth. And not just 1 or 2,000, up to 30,000 teeth over their lifetime to be precise. Yeah, I wouldn't want to see a shark's dentist bill. Something to chew on. Scientists have yet to identify a creature on Earth that can actually live forever, but it looks like this is about to change. A tiny jellyfish that's even smaller than the nail on your pinky appears to be the living embodiment of Benjamin Button. That's because it has the ability to go back to a previous developing stage whenever it's endangered or extremely hungry and out of food. It's no surprise they earned themselves the nickname the immortal jellyfish. We've known about this species for hundreds of years, but it took us until the 1990s to discover their unique characteristics. We're yet to be sure how it's able to produce cells that regress and regrow, but they could hold a secret that might help advances in medicine for both animals and humans. Ooh, mysterious mountain ranges hidden under thousands of tons of ice. bizarre transparent creatures with see-through skin, singing snow plains. Antarctica has its own terrifying secrets. And now, a mysterious ice hole the size of Switzerland that keeps popping open, and scientists have finally figured out why. This hole, called the Maud Rise Polynya, was first spotted in 1974 and 1976 in the Weddell Sea. Since then, it's been kind of playing hard to get. Sometimes it appears, sometimes it disappears for years. And when it does show up, it mysteriously changes size. For decades, researchers were trying to figure out what makes it form. Then, in 2016 and 2017, the Polynya went absolutely massive, more than 30,000 square miles. The hole stuck around for several weeks during winters. It was the first time since the 1970s that the Weddell Sea had such a huge, long-lasting Polynya. Here's the deal with Antarctic sea ice. In summer, the ice is at its smallest, around 1 million square miles. Yeah, that's considered small. By winter, it spreads to a whopping 7 million square miles, covering about 4% of Earth's surface in weird white tiles. Most of this ice grows during the weeks-long polar night on the floating ice shelves around the continent. These holes in the ice, called polynyas, usually form when strong winds from inland push the ice tiles apart. That same cold wind also freezes more seawater inside the hole, adding extra chunks to the ice sheet. But the Maud Rise Polynya isn't near the coast, where those winds normally help make holes. Out in the open ocean, holes like this are rare. Add in the fact that ice across the Southern Ocean has been shrinking. No wonder scientists are left bewildered. What exact conditions are creating this stubborn giant ice hole? To crack the mystery, the scientists dove into a mountain of data: satellites, floating sensors, even info from tagged marine animals. Plus, they had years of past observations from other researchers. And they found something unusual. In 2016 and 2017, the Weddell Sea's circular ocean current, called the Weddell Gyre, was stronger than usual. That extra punch made it easier for salty, warmer water from deep below to reach the surface. The Maud Rise Polynya sits above an underwater mountain called Maud Rise. During those big Polynya years, the stronger current caused salt to gather around this submerged peak. On the surface, the wind whipped over the ice, creating a corkscrew effect. It literally pulled that salty water up from below. The extra salt lowered the freezing point of the surface water, allowing the Maud Rise Polynya to form and stick around. Polynyas are really important for the planet. The dense salty water formed in these holes can travel huge distances, spreading across the global ocean and affecting climates everywhere. But these magnificent holes aren't the only cool and mysterious phenomena Antarctica is famous for. How about underground lakes? Or shall I say under-ice lakes? Because there are entire lakes hidden under Antarctica's thick ice. Scientists first found them back in 1970 using radar, and now they think there are around 400 lakes tucked under around 2 miles of ice in the explored areas. These lakes likely formed after Antarctica broke off from Gondwanaland, the ancient supercontinent. Surprisingly, the water in the lakes doesn't freeze because the ice above presses down too hard. Hey, it's physics, bro! The biggest of them all is Lake Vostok, discovered in the 1990s. It sits a bit more than 2 miles below the ice. Scientists have drilled down to take samples, and the water they pulled up was about 26 degrees Fahrenheit, even though the lake had been trapped under ice for over 20 million years. There's also Lake Williams. In 2014, scientists made a lit discovery there. They found a thriving colony of microorganisms nearly a mile under the ice. Those tiny creatures never saw sunlight or fresh air. Instead, they used methane and ammonium as energy to grow. Another marvel hides in plain sight in the McMurdo Dry Valley. It's a waterfall that looks like something straight out of a horror movie. Bright crimson water, like blood gushing from a wound in the ice, pours down 5 stories from Taylor Glacier into Lake Bonny. Ooh, spooky. But there's actually a scientific reason behind it. The water that feeds Blood Falls used to be part of a salty lake. Now, it's completely cut off from the atmosphere because glaciers formed on top of it. Trapped more than 1,300 feet underground, the water has become super salty, 3 times saltier than seawater, and it can't freeze. This underground water is also packed with iron and completely lacks oxygen in sunlight. When it slowly seeps through a crack in the glacier and hits the open air, the iron oxidizes, basically rusts, and turns the water that eerie dark red. With such creepy landscapes, Antarctica might look like a frozen wasteland, freezing cold, almost no rain, and winds that could knock you off your feet. The coldest Earth's temperatures ever was recorded there, minus 128.6 degrees Fahrenheit. And still, Antarctica is actually home to some seriously bizarre wildlife. For the longest time, scientists thought nothing could survive under all that ice. Turns out, they were very wrong. There are all sorts of creatures that have adapted to the brutal environment. Tiny microbes, crustaceans, colossal squid, and spiders so big their legs could cover a dinner plate. Giant worms with shiny golden bristles and huge sharp-toothed jaws also lurk under the ice. And then there's the ice fish, a completely see-through fish with huge eyes and organs you can literally see through its skin. These fish have built-in antifreeze proteins to survive the freezing waters, and they can't live anywhere warmer. Even stranger, they don't have hemoglobin, the protein that makes our blood red. In other words, they survive without the stuff that literally keeps most animals alive. But Antarctica wasn't always the frozen desert we know today. Millions of years ago, before the Ice Age, it was actually warm, lush, and full of life, maybe even home to ancient civilizations. Hard to imagine, huh? Scientists figured this out after finding fossilized wood, tropical tree remains, and leaf impressions, all pointing to the existence of rainforests. On top of that, they've uncovered fossils of marine animals, birds, and dinosaurs from the Cretaceous period. Even tiny creatures left their mark. Fossilized beetle wings from 14 to 20 million years ago, single-cell fossils, and, astonishingly, 50-million-year-old sperm cells preserved in the egg case of an extinct worm. So now, it probably won't shock you when I tell you that beneath Antarctica's thick ice sheets, there's a massive hidden mountain range. The Gamburtsi Mountains stretch for 745 miles and rise to almost 10,000 feet, about the third the height of Mount Everest. And all this is buried under between 6,500 to 13,100 feet of ice. The mountains were discovered in 1958. Scientists noted a thin patch of ice and some weird gravity readings while crossing the continent. Even though no one has ever seen those mountains directly, researchers use radar to map their shape and gravitational and magnetic readings to study them all the way to their base. Perhaps the craziest part is that the Gamburtsis are around 1 billion years old. So, in theory, they should have eroded away long ago. How they're still standing is a mystery. Most scientists think a frozen mantle beneath the ice might be protecting them from erosion, keeping this ancient range intact. And finally, Antarctica has its own soundtrack. The Ross Ice Shelf, the continent's largest ice shelf, is several hundred feet thick and spreads over 193,000 square miles, roughly the size of France. And scientists have recently discovered that this massive ice slab actually sings. The eerie melody comes from wind blowing over snow dunes, which creates vibrations in the ice and a nearly continuous seismic hum. You can't hear it with your ears, but seismic sensors pick up the mournful tune. In fact, it was discovered by accident. Scientists just installed special sensors to monitor other ice behaviors. Now, even cooler, the song changes depending on what's happening on the ice. Melting, storms, and shifting snow all tweak the vibrations. Researchers are now using this haunting melody as a kind of early warning system. They listen to it in real time to track the ice shelf stability and potential collapse.
A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever ANITA has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They publish the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Wiesel and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, Researchers have been designing setups in both Antarctica and South America to catch these rare particles. ANITA is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from ANITA's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what ANITA had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Wissel explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas, like maybe it's some new kind of physics, or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since IceCube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.
Giant vase-like sponges, otherworldly jellyfish, segmented worms covered with bristles, and large octopuses are the newest Antarctica discovery. Scientists found them after a giant iceberg had broken away, and it turned out to be a treasury of ancient life under ice. In January 2025, a huge iceberg the size of Chicago, called A84, broke off from Antarctica's George VI ice shelf, which is a large ice shelf about 280 miles long, 12 to 43 miles wide, and around 820 feet thick. In the summer, which lasts from November to late February, the ice shelf melts at the surface, and meltwater ribbon lakes form. They're elongated and ribbon-like. That's how they got their name. Anyway, when the iceberg floated away, it left part of the ocean floor wide open, and it was a spot no one had ever seen before. Scientists on the research ship Falkor 2 were nearby in the Bellingshausen Sea. As soon as they heard about the iceberg, they immediately changed their plans. They understood that it was a super rare chance to check out something unknown and amazing, like lifting a rock in the forest to see what's hiding underneath. The researchers used an underwater robot named Sebastian and explored the deep sea for 8 days. They went as deep as over 4,200 feet. Down there, they found a hidden ecosystem. There were big corals and sponges literally packed with sea animals. A whole world under the ice. The researchers thought they'd find some life down there, but they didn't expect to see so much. And this underwater ancient life wasn't just surviving, it had been thriving in that harsh, icy place for a really long time. Anemones that looked like fluffy little trees, sea spiders, ice fish, octopuses. The research was live streamed to scientists from all over the world, and those live streams are actually in open access. The coolest thing was that some discovered creatures seemed to be new species. Yes, there are probably new species in Antarctica in 2025, and some might only live in this region. That's because Antarctica isn't just really far away. It's been cut off from the rest of the world for millions of years. The Antarctic circumpolar current surrounds it, like a big water moat surrounding a castle. But even if it turns out that those species are not new, the scientists have still found snails, worms with bristles, crustaceans, like tiny crabs and shrimp, and a species of the phantom jellyfish. Those are super rare and look otherworldly. Their official name is too complicated, so let's just call them the giant phantom jelly. This jellyfish is huge. Its bell, the round umbrella part on top, can be more than 3 feet wide. It has 4 long arms that trail behind it. Each one as long as 33 feet, about as long as a school bus. Scientists first caught one way back in 1899, but it took them 60 years to realize it was a totally new kind of jellyfish. The phantom jellyfish has a see-through purplish body that looks kind of ghostly. Instead of normal jellyfish tentacles, it has these ribbon-like arms that help it catch food and pull it into its mouth right in the middle. Even though jellyfish don't have brains like we do, researchers watching the giant phantom jelly noticed something surprising. The otherworldly creature seemed to move its arms very carefully and with control, especially when swimming through tight spaces on the seafloor. It looked like it was being very cautious and deliberate. Ugh, creepy. Another sentient being? Jellyfish have a simple nerve net instead of a brain, which helps them sense the world around them. But the way this phantom jelly moved made scientists think it might be smarter or more coordinated than other jellyfish. Studying it can help scientists learn how animals without brains still manage to explore and survive in tricky places underwater. Another cool find was little worms called bristleworms. Scientists call them polychaetes. But let's stick with bristleworms because it kinda sounds fun. Lots of different kinds of them live in super cold, deep parts of the ocean. Bristleworms have bodies made of many segments, and they have tiny little bristles all along their sides. These bristles help them move around, feel what's near them, and even protect themselves from danger. One cool example is the Antarctic scaleworm. It's a type of bristleworm that lives in really cold, deep waters and has shiny, golden bristles that make it look pretty fancy. During Antarctic deep-sea exploration, the team also found giant sponges shaped like vases. Usually, sponges grow very slowly. So to get that huge, they must have been growing there for a really long time, maybe even hundreds of years. Their size shows that the deep-sea animals living around them didn't just move in recently. Those sea creatures have been there for decades and managed to form thriving communities under the ice. So, it really was ancient life hiding under all that ice. And that surprised scientists a lot. In older studies, people used to drop cameras through holes in the ice or visit iceberg areas long after the ice had broken off to explore hidden ecosystems. Back then, they mostly saw bare, empty seafloor with just a few living things. But this time, the team arrived just weeks after the giant iceberg broke away, and they got to see what was hiding right underneath it. The first 9 miles behind the ice shelf can hide rich and busy ecosystems. The area is dark, cold, and hidden for ages, and still, all kinds of creatures live there. This shows that life can survive in places that seem too harsh or frozen for anything to live. On the other hand, finding all this life down there isn't super surprising. Lots of animals live in dark, cold places underwater, so it makes sense that they'd be under the ice shelf too. The ice kind of hides them and keeps them safe from anything going on above. But what's weird is how many different kinds of creatures live there, even though it used to be a really closed-off space. It actually looks a lot like the seabed in parts of Antarctica that don't have ice on top. How can that be? Usually, tiny plants called phytoplankton grow near the surface where sunlight hits. Little shrimp-like animals called krill eat those plants at night. When krill get full, they sink down and bring food and nutrients to the ocean floor. Even their waste helps feed the deep-sea creatures. But if there's a huge ice cap above, sunlight can't get through, so no plants can grow there and no krill bring food down that way. Scientists thought this would mean less food and fewer animals down there, but they found a lot of life anyway. Turns out, food and nutrients probably sneak in under the ice, carried by underwater currents, kind of like rivers flowing under the ocean. Scientists found some animals that lived a long time, so it looks like those currents, which mostly come from melting glacier water, bring enough food to keep the ecosystem healthy and full of life. No one really knows what's going to happen to all that deep-sea life now that the iceberg has floated away. Those creatures have lived under the thick ice for who knows how long, in super stable, pitch-black conditions. Obviously, they're not exactly fans of change, so losing that icy roof might totally mess with their whole setup. One of the scientists mentioned that the ice shelf the iceberg came from has been creeping backward, like 25 miles over the last 50 years. That's a part of a bigger pattern. Antarctica's ice is melting faster and faster, which pushes sea levels up around the world. That's why this Antarctica discovery matters. The team's trying to figure out not just what's happening now, but how this hidden ecosystem fits into the bigger picture. If we can understand how this place is changing over decades or even centuries, maybe we can predict what's coming next. And it's pretty amazing that breaking ice can tell us so much, right?
A hole about the size of Switzerland or South Carolina keeps popping up in the Antarctic ice. This opening is growing steadily, and it took scientists half a century to figure out why. They found the answer with the help of seals. The scientists first spotted this gap, called Maud Rise Polynia, in the Weddell Sea in 1974. They were about to close the case as the hole disappeared, but it popped out again in the following 2 years, and then only in 2016. The giant hole is near Maud Rise, an underwater mountain. This type of hole is a polynia, a rare patch of open water surrounded by thick sea ice. In Antarctica, when winter hits, the ocean surface freezes, and sea ice spreads out to cover an area about twice as big as the continental United States. Along the coast, openings in the sea ice pop up every year. This happens when powerful coastal winds blow off the continent and push the ice away. But it's a whole lot rarer for these openings to form way out over the open ocean, hundreds of miles from land, where the water is thousands of feet deep. Researchers from several universities teamed up to study the Maud Rise Polynia using computer models and satellite images. They even recruited some Antarctic seals to help out. These seals wore tiny helmets on their furry round heads with tracker sensors attached to them. Thanks to these sciencey seals, the team could collect water data from the source. After the research, the scientists discovered that the hole resulted from a complex mix of factors. The wind, ocean currents, and the special shape of the ocean floor all worked together, moving heat and salt up to the surface. In science talk, this swirling movement is called an Ekman transport. Ekman transport is what happens when wind messes with the surface of the ocean. When the wind blows across the water, it creates friction that grabs onto the top layer and pulls it along. Thanks to the Coriolis effect, which comes from Earth's spinning, the moving water gets pushed at a 90-degree angle from the wind's direction. So, instead of the water going exactly where the wind is pushing it, it drifts off at an angle. Which way it turns depends on which half of the planet you're on. In the northern hemisphere, the water shifts clockwise from the wind direction, and in the southern hemisphere, it shifts counterclockwise. Now, Ekman transport turned out to be the missing piece of the puzzle in the case of the Maud Rise hole. It helped balance the salt levels and keep mixing salt and heat up to the ocean surface. But as the sea ice melts, the surface water becomes less salty, which should stop the mixing. So the scientists realized something else had to be happening to keep the Paulownia open. There had to be another source of salt. Salt lowers the freezing point of water. To find out where this extra salt was coming from, the team dug back into their data and ran more computer models on the ocean. They found that swirling currents formed as the Weddell current flows around Maud Rise. These currents carry salt up to the top of the underwater mountain. From there, Ekman transport kicks in. As the top layer of water moves away with the wind, water from deeper down rises to take its place. At Maud Rise, this upwelling water brings along the extra salty water built up around the seamount, and that's what helps keep the Paulownia from freezing over. Scientists follow any changes in Antarctica as they influence the rest of the world. Researchers at Stanford University used machine learning for the first time to study detailed satellite data showing how ice moves in the polar region. They combined huge amounts of real-world data with physics rules to understand the Antarctic ice sheet better. It's the biggest ice mass on Earth, almost twice as large as Australia. It acts like a giant sponge for the planet, storing fresh water as ice and stabilizing sea levels. Scientists used to rely on models based on lab experiments, but real Antarctic ice is way more complex, with cracks, air pockets, and different types of ice that behave unpredictably. Instead of trying to model every little detail, the team trained a machine learning model using data from 2007 to 2018. It looked at 5 major ice shelves and created new models showing the ice's resistance to flow. They found that near the land, the ice is compressed and behaves as in lab predictions. But farther out, the ice is stretched toward the ocean and acts differently depending on direction. Less than 5% of the ice shelf is compressed. The other 95% behaves in a way old models didn't fully explain. This research could seriously improve our predictions of how Antarctica might change in the future. Another recent piece of big scientific news from Antarctica changes the history of birds as we know it. For a long time, it was simple. Dinosaurs ruled the Earth until an asteroid hit 66 million years ago and wiped them all out, except for some avian dinosaurs, which eventually became birds like eagles and chickens. Now, scientists have found a headless fossil of a VYI on Vega Island in Antarctica. The fossil was 68 million years old, at least 2 million years older than the asteroid strike. Without a skull, it was unclear what modern birds VYI might be related to, and guesses included waterfowl and shorebirds. Nearly 20 years later, another expedition found a bird's skull in Antarctica. After careful study, scientists matched it to VYI and concluded it was an ancestor of modern water birds like loons and grebes. If it's all true, VYI is now the oldest known modern bird in fossil records. The skull had a long, pointed beak, a brain unlike any other Mesozoic bird, and signs of strong jaw muscles like mine, which were perfect for diving underwater and catching fish. The body fossil also had adaptations for underwater swimming, similar to modern diving birds. During the late Cretaceous period, Antarctica was a temperate rainforest far from the Yucatan, so it could have become a safe haven during the asteroid disaster. So, early modern birds might have survived there. When a giant iceberg, about the size of Chicago, broke off from Antarctica's massive ice shelf, scientists nearby did something no one had ever done before. They sailed straight over to check out the newly exposed seafloor. Studying the undersides of ice shelves is incredibly hard, but thanks to the iceberg A84, a 209 square mile patch of seafloor suddenly opened wide for exploration. The scientists deployed all their high-tech gear, including a remotely operated submersible and autonomous robots, to collect data about the seafloor and the properties of the water above it. Life exists almost everywhere in the ocean, from the bright, shallow waters to the pitch-black, volcanic deep sea. But the research team was really surprised to find such a diversity of life down there. They found a forest of sponges, giant sea spiders, icefish, octopuses, huge corals, anemones, and even glowing deep-sea jellyfish. Normally, deep-sea creatures get their nutrients from organic matter falling from the ocean surface. But under a 500-foot thick sheet of ice that had been there for who knows how long, that wasn't possible. That meant the creatures had to be getting their nutrients in some completely different way. To figure out how long this hidden ecosystem had been around, the scientists studied the sea sponges. Sponges grow extremely slowly, only about an inch per year, but the ones they found were huge, so they must have been growing there for decades or even centuries. The team is hoping that the mountain of ocean and environmental data they collected during the expedition will help them understand how these ecosystems managed to thrive in those conditions and maybe reveal some completely new species that no one has ever seen before. Ooh, you're diving into the dark and icy waters of Antarctica. The eerie blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well. Off the western coast of Australia and near New Zealand, they recorded similar but higher pitch signals, which they named bio-goose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on bioduck and biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The biogoose sounds from the waters off Australia and New Zealand likely belong to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a "hey" of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike bioduck, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping, reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales, specifically Bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of Bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound source was a giant sea monster, kraken, or some other creature. The hype around the bloop didn't last very long. Scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. How about we end this video with a mystery that still baffles scientists? Meet upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it.
Scientists punched through more than 1,600 feet of ice and finally solved the billion-year-old Antarctica's magnetic mystery. Their find also completely changes our understanding of how continents collided and merged around the same time. But first things first. Several decades ago, scientists were running geophysical surveys in Antarctica and noticed stripes of magnetic highs and lows, areas where the crust magnetizes differently than everything around it. Nobody could figure out the cause. Researchers started mapping those magnetic anomalies in the early 1960s. Back then, they used airborne magnetic surveys that flew lines across the ice to detect unusual magnetic signals. They linked those magnetic anomalies to volcanic rocks hidden beneath the ice sheet. By the mid-1990s, international scientists launched an entire project to map Antarctica's magnetic anomalies across the entire continent. They put together millions of miles of magnetic survey data from airborne lines, sea, and even observations from space, and managed to produce the first continent-wide magnetic anomaly maps by the end of the 1990s. Those maps show how Antarctica's crust formed and changed through time. So they knew what was going on there, but couldn't explain why it happened like that. To get answers, researchers from St. Petersburg State University teamed up with scientists around the world to study one of the hardest places to work on the planet. Antarctica sits smack on the coldest winds on Earth, with ice sheets of about 1.5 miles thick on average. And that ice doesn't just sit there. Over millions of years, it grinds rock, buries valleys, and hides everything beneath its fractured frozen blanket. To reach the ancient bedrock that held the magnetic mystery, researchers had to drill over 1,700 feet of ice before they could even pull up samples from the underlying crust. When they brought those rock samples back to the lab, they turned out to be pieces of ancient volcanic island arc. There were entire chains of volcanoes that formed above subduction zones, similar to the Aleutian Islands in Alaska or the island arcs near Japan. In the lab, scientists looked at chemistry, measured magnetic minerals under microscopes, and used radiometric dating. This method reads the decay of unstable atoms to figure out the age of an object. And all this helped them determine that these rocks had a completely different origin than typical Antarctic crust. The team found that this volcanic island arc didn't just drift nearby. It collided with East Antarctica when the supercontinent Rodinia was in the forming stage. Rodinia gathered nearly all of Earth's landmasses into one colossal formation, and when that volcanic arc crashed into East Antarctica, it welded into place like two tectonic puzzle pieces, locking together. That collision left behind a distinctive magnetic signature, one that satellites can still detect today. The way these rocks recorded magnetism makes perfect sense once you understand a little bit about magnetic minerals. When molten rock cools, iron-rich minerals like magnetite align themselves with Earth's magnetic field, pretty much like tiny compass needles freezing in place. Over geological time, these locked-in magnetic directions act like memory sticks. When scientists studied the Antarctic samples, they found magnetic directions that didn't line up with ancient Antarctica's old magnetic field, but did line up with where that volcanic arc would have been long ago. That magnetic memory showed that the rocks didn't grow in place, but traveled and slammed into Antarctica. Alongside magnetic clues, scientists also compared gravity measurements from satellites and ground surveys, and found even more evidence that the rocks beneath East Antarctica weren't ordinary. Some regions of Antarctica have slightly weaker or stronger gravity depending on the density of rocks buried beneath the ice. Denser rock, like ancient volcanic crust, produces a slightly stronger gravitational pull. If you picture lying on a mattress, the way it dips over a bowling ball differs from where there's only foam. That's how gravity variations tell scientists something unusual lurks below. Those gravity patterns matched where the weird magnetic rocks were coming from. It only backed up the idea of an exotic chunk of crust attached to Antarctica's edge. And these findings show us that Rodinia's formation wasn't tidy or orderly. Bits of crust from far-off places got plastered onto Antarctica's edge and became clues that waited a billion years for scientists to dig them up. Over time, heat, pressure, and tectonic forces buried and reshaped those rocks, but their magnetic fingerprints survived. Another Antarctic mystery scientists recently solved is the secret of Blood Falls. Yep, as the name suggests, it's blood-red water pouring out of a glacier, and no one could explain what gives it its color. Back in September 2018, a camera captured the falls suddenly coming alive. At almost the same moment, instruments sitting on top of the glacier recorded something odd. The ice surface actually dropped slightly. The glacier sank, the red water flowed, and then the ice slowly lifted back up again weeks later. So beneath all that heavy ice, there is salty water locked away for ages. The glacier presses down constantly, squeezing that hidden water harder and harder. When the pressure builds too much, the ice shifts, opens somewhere deep below, and the trapped liquid rushes out in a sudden pulse. Blood Falls acts like a pressure valve for the glacier. Salt turns the water into a thick brine that refuses to freeze, even in Antarctica's brutal cold. Over thousands, maybe millions of years, freezing concentrated the salt more and more. It left behind a liquid that can still move through solid ice. Scientists believe minerals from buried rocks feed that salty mix and give us clues about what lies far below the glacier. The red color makes the whole scene look dramatic, but the explanation for it is surprisingly simple. Underground, the water carries dissolved iron. The moment that liquid touches air, the iron reacts with oxygen and turns rust red, just like metal left out in the rain. Within minutes, bright crimson stains spread across the white ice. Cameras near the falls showed fresh red staining spreading day by day. At the same time, temperature sensors deep in the lake where it flows recorded sudden cooling. Dense brine had slipped into the lake underwater and disturbed layers that normally stay perfectly stable. Even small disruptions matter here, since life survives in narrow zones where nutrients barely exist. As the drainage continued, scientists noticed the glacier slowed down too. With less water acting as lubrication underneath, the ice pressed harder against the rock below and moved forward more slowly. All this means that hidden water controls how fast entire glaciers slide across Antarctica. Some observations from the air also showed salty groundwater pathways stretching miles beneath the valley floor. The brine doesn't just sit under the glacier, but travels through rock and ice before finally escaping at Blood Falls. And deep inside that dark, oxygen-free water, there's life. Microbes live off iron and sulfur instead of oxygen and thrive in total darkness for millions of years. This ancient liquid may have stayed sealed beneath the ice long before humans even existed. Lake Enigma is another cool discovery from Antarctica with a twist. For a long time, researchers thought it was completely frozen solid. But during one expedition, they found that under the thick ice, there was a layer of liquid water about 40 feet deep. To learn more, they drilled through the ice and sent down a camera to explore what was hiding in the lake's depths. The lake's water, which they think comes from the nearby amorphous glacier, through a secret underground pathway, was filled with strange microbial life. These tiny microbes lived in mats that covered the lake bed. Some of the mats were thin and spiky, and others looked like crumpled carpets or even small tree-like shapes that grew up to 16 inches. Many of the microbes could make their own food through photosynthesis, just like plants do, and gave the lake a high amount of oxygen. One of the coolest discoveries was a type of microbe which usually lives in low-oxygen places. Lake Enigma might be similar to environments on icy moons like Europa or Enceladus. So it could mean that these moons also have hidden water under their ice and possibly microbial life too.